Ladies and gentlemen, the Kavli Prize Ceremony 2012 has the honor of introducing the first Master of Ceremonies, Åsa Kleveland.
Madam Minister, laureates, excellencies, ladies and gentlemen, it is a great joy and a pride to welcome you all to Oslo Concert Hall and to the Kavli Prize Award Ceremony 2012. I am delighted that this year, as last time, I am going to share the floor with an extraordinary gentleman. He's a writer, an actor, a director. He has won Emmy Awards, Golden Globe Awards. He is an Academy nominee, and you all know him from MASH and from West Wing and from a number of appearances in the movies. But in addition to this, he is also known as a popularizer and presenter of science. And for many years, he served as host for the PBS series Scientific American Frontiers. So guess who? Please welcome Mr. Alan Alda. It's great to have you back in Oslo again.
Thank you. I love being here. Thank you. And to be on stage with you.
So, here we are, two people from art and culture presenting 7 pioneering scientists, some of the foremost representatives of natural science in the world.
The Kavli Foundation is dedicated to advancing science for the benefit of humanity, promoting public understanding of scientific research, and supporting scientists and their work. The Foundation conducts an international program in research institutes, professorships, and symposia, and it's the founding partner of the Kavli Prizes.
And the 3 Kavli Prizes are awarded every 2 years, and they consist of a medal, a diploma, and $1 million each. And the awards are presenting in cooperation between the Kavli Foundation, the Norwegian Academy of Letters and Science, and the Norwegian Ministry of Education and Research.
The Kavli Prizes stand out because of their size, of course, but also because they've been inaugurated and sponsored by one private individual, the physicist, inventor, businessman, and philanthropist, Fred Kavli. 10 years ago, Fred Kavli established the Kavli Foundation, and thanks to him this year, the Kavli laureates are being honored for the 3rd time. The prizes are awarded for their work in nanoscience, astrophysics, and neuroscience, or as Fred Kavli likes to say, for the smallest things in the universe, the largest, and the most complex.
This year's laureates were selected for their fundamental contributions to our understanding of the outer solar system, the differences in material properties at nano and larger scales, and how the brain receives and responds to sensations such as sight, sound, and touch.
Ladies and gentlemen, the time has come to award the Kavli Prizes for 2012. And the ceremony opens with a procession by the President and Vice President of the Norwegian Academy of Science and Letters. Those not in the procession, please remain seated. It is my great honor to ask His Majesty King Harald V to take his seat on the stage. The King will be accompanied by the Secretary General, Øyvind Andersen, of the Norwegian Academy of Science and Letters. Please all rise.
We wish this award ceremony to be a meeting between science and art, represented today by music. And most of the laureates that we honor here today are passionate music lovers, be it classical music or rock and roll. Some of them are even musicians, and this is no coincidence. They follow in an old tradition, with Charles Darwin as one of the forefathers. According to Darwin, mankind had the ability to create and to enjoy music long before we even had a verbal language. And that was the reason, according to Darwin, that music affects us in such a subtle manner. It brings to life the vague memories of centuries past, an age now shrouded in mist when the world was young. I'm so happy to present to you Oslo Kamerata. It's one of Norway's foremost chamber ensembles with performances all around the world. Well, we might as well call it the Kavli Prize Orchestra, as it has been with us from the very beginning. Oslo Kamerata is conducted by Stefan Barrat-Due Jr. He is CEO and artistic director for the Music Institute of Barrat-Due. And that is Norway's #1 institution for development of musical talent, of which you will hear some examples today. So we would like to offer you one of the Norwegian treasures, the Prelude from the Edvard Grieg's Holberg Suite.
I'm honored to give the floor to the president of the Norwegian Academy of Science and Letters, Niels Christian Stenseth.
Your Majesty, dear Minister of Education and Science, dear Fred Kavli, dear Excellencies, dear prize winners, ladies and gentlemen. On behalf of the Norwegian Academy of Science and Letters, it's a great pleasure and honor to welcome you to this year's Kavli Prize Award ceremony. Today, science has an enormous impact on our health, economic standard, and overall quality of life, and continues to be of increasing importance. These are the words of Fred Kavli, chairman and founder of the Kavli Foundation. I wholeheartedly agree. Indeed, modern society cannot be imagined without basic and long-term curiosity-driven scientific enterprise. This afternoon, 7 outstanding scientists will be honored for the groundbreaking discoveries and outstanding work in the 3 disciplines covered by the Kavli Prizes: astrophysics, nanoscience, and neurobiology. Each of these disciplines represent exciting and fast-growing areas of scientific research in which new discoveries and insight have a strong impact on society, as highlighted by Fred Kavli. Honoring outstanding and highly creative scientific research through the Kavli Prize helps raise awareness of the importance of basic science. It is a work of outstanding scientists of the kind we are celebrating today that produces the insight modern society depends on, be it for our health, economic standard, or overall quality of life. In this respect, excellence in the basic, curiosity-driven, and long-term scientific effort of the kind celebrated through the Kavli Prizes is of fundamental importance. The Kavli Prizes were established in order to highlight the importance of excellence in science, or the methodologically solid scientific enterprise. It is the methodologically solid scientific enterprise we all depend on, and which Fred Kavli refers to in the quote I gave to you a short while ago. The Kavli Prize is a partnership between the Norwegian Academy of Science and Letters, the Kavli Foundation, and the Norwegian Ministry of Education and Research. The Norwegian Academy of Science and Letters has been given the responsibility of selecting the Kavli Prize winners. This is done via 3 international selection committees, 1 for each of the fields covered by the Kavli Prizes. These selection committees do indeed represent the international scientific community, with members nominated by some of the most influential international scientific bodies. These are the Chinese Academy of Science, the French Academy of Science, the Max Planck Society in Germany, the National Academy of Science in the US, and the Royal Society of London. On behalf of the Norwegian Academy of Science and Letters, I'd like to thank the prize selection committees for doing such an excellent job for us, for the prize, and the entire scientific community. The Kavli Prize has 2 missions in addition to recognizing outstanding scientific research and honoring highly creative scientists. These are to promote public understanding of scientists and their work, and to foster international cooperation among scientists. The former is achieved largely to the broad publicity the Kavli Prizes receives, both nationally and internationally. The prize and the entire Kavli Prize Week highlight the value and productivity of science through the work of prize winners and their colleagues. I do, on behalf of the Academy of Science and Letters and the entire scientific community, wholeheartedly thank all those who in various ways have contributed and indeed are contributing to the many events of the Kavli Prize Week, be it here in Oslo, in Bergen, or in Trondheim. It is all these events which together highlight the importance of the methodologically solid scientific enterprise. On behalf of the Norwegian Academy of Science and Letters, I also like to thank our partners, the Kavli Foundation and the Norwegian Ministry of Education and Research. Through our different networks, we spread the word much more effectively than each of us could have done alone. I'm convinced that the attention the Kavli Prizes receives raises awareness of the importance of the scientific enterprise, and thus aids those politicians, like our Minister Kristin Halvorsen, responsible for creating effective platforms for the scientific enterprise, be it in Norway, in US, or anywhere in the world. The latter mission of the Kavli Prize, fostering international cooperation among scientists, is achieved by the global attention of the Kavli Prize, which the Kavli Prize receives. To emphasize the global nature of science, we organized the Kavli Prize Science Forum, carried out yesterday afternoon here in Oslo. The topic of the forum was science and global health. If we are to improve the health condition locally as well as globally, we need an international partnership between a broad spectrum of expertise and institutions. It is my hope that the Science Forum of yesterday contributes to foster such international and intersecretarial partnership of the kind set out by President Obama and our own Prime Minister's global health initiatives. Distinguished guests, and our acclaimed Kavli Prize winners. Once again, I welcome you all to this year's award ceremony, a great day for science and the long-term basic curiosity-driven scientific enterprise. I welcome you to this celebration of excellence in science. Welcome.
Science is not just about uncovering the secrets of the universe and of nature, but it's also about breaking barriers in all senses of the world. And in this context, this year's Kavli Awards represent a milestone. The first 15 Kavli laureates were very different in many ways, but they had one thing in common. They were all men. This year, 4 out of 7 laureates are women, as is the first Kavli laureate to receive the prize on her own. This does not only make them outstanding scientists in their own right, but also crucially important role models in a world where it is still too common for scientifically minded women to encounter prejudice and resistance. You will now meet a young Norwegian artist who has broken many musical barriers, singing funk, jazz, soul, working with music, with theater, you name it. Her name is Julie Dahler Aagaard, and she will sing a song to which she has written the lyrics herself, and our conductor for ceremonial and light music, Staffan William Olsson, is the composer. And the name of the song is Worth Waiting For.
I will be gazing at the stars the day I know how we got this far. I will chase the sun the day I know how it all began. To my heart, the day that I create a brand new start, I will rise this day when I find a way. My mistakes can only make me stronger, but my heart beats like a drum. I need to know I can't wait any longer. Life's a mystery. Let's change our history, 'cause I will be holding your hand the day we realize and understand that we can be amazed by answers we embrace, 'cause it will be worth waiting for. My mistakes can only make me stronger, but my heart beats like a drum. I need to know I can't wait any longer. Life's a mystery. Let's change our history, 'cause I will be holding your hand the day we realize and understand that we can be amazed by answers we embrace, and it will be worth waiting for. And it will be worth waiting for.
Astronomy is usually about something incredibly far away. But a few months ago, Oslo got a loud reminder of how crowded our system is. Just 2 kilometers from where we are right now, a large meteorite crashed through the ceiling of a small cottage. For weeks afterwards, meteorite hunters have been trawling the parks of Oslo, trying to find just the tiny little fragment of this visitor from space. And some of them might still be out there while we are speaking.
Oh, good. The rocks that fall from the sky, of course, are a small fraction of the billions of objects that orbit our sun. In addition to the 8 planets and their moons, there are asteroids, comets, and rocky and icy bodies of all shapes and sizes. And we're sure to be able to learn about the solar system from all of these objects, but maybe none more so than those orbiting in the blackness beyond our most distant planet, Neptune. There, extreme cold has preserved the chemical composition of the early solar system, creating a time capsule just waiting to be opened.
And the pace of discovery in the outer solar system was underscored this year in July with the announcement of a 5th moon in orbit round Pluto, which used to be the outermost planet. The demotion of Pluto to a dwarf planet, largely a result of research done by this year's laureates, got a lot of attention in 2007.
Particularly by students who had to wave goodbye to their favorite planet and also give up their mnemonic for remembering the planets, which was okay by me. I never could remember the mnemonic. And in any case, it's time to honor the 3 scientists with the Kavli Prize in Astrophysics. The 3 laureates are David Jewett, Jane Liu, and Michael Brown. It's an honor to welcome the chairman of the prize committee for the Astrophysics Award. To justify the award, Dr. Oddbjørn Engvoll is a professor at the Institute of Theoretical Physics at the University of Oslo and former Secretary General for the International Astronomical Union.
The 2012 Kavli Prize in Astrophysics is awarded to David Jewett, Jane Liu, and Michael Brown for discovering and characterizing the Kuiper Belt and its largest members, the work that led to a major advance in understanding the history of our planetary system. The present constitution and structure of the solar system are the result of intricate processes under which the primordial material formed planets, a wealth of larger bodies, smaller bodies, and debris. In the 1980s, our picture of the solar system was an inner part with planets, asteroids, and comets, and an outer part a region which appeared unreasonably empty. The apparent emptiness of the region beyond the orbit of Neptune remained a central puzzle that was challenged and successfully explored by the 3 recipients of the 2012 Kavli Prize in Astrophysics. Jewett, Liu, and Brown discoveries were each the result of cleverly designed observation campaigns aimed specifically at detecting new classes of objects, distant objects in our solar system. These campaigns required creative strategies and a great deal of persistence and an open-minded approach to expect the unexpected. Based on their detection techniques for slowly moving objects, David Jewett and Jane Liu spotted in 1992 the very first Kuiper Belt object, now known as QB1 1992. Their subsequent survey showed that the Kuiper Belt is a vast repository of icy remnants, bodies of which more than 70,000 are larger than 100 kilometers in diameter. The composition and orbital characteristics of Kuiper Belt objects offer a unique probe into the solar system formation 4.5 billion years ago. Michael Brown designed and implemented the Caltech Wide Area Survey, which covered a large angular area in the plane of the solar system. This survey was specifically optimized for detecting the most massive Kuiper Belt objects. Brown's discovery of Quaoar in 2002, of Makemake and Eris in 2005, and many other large Kuiper Belt objects made it clear that Pluto is only one out of many such objects. The fact that Eris and Pluto are closely similar in size, whereas Eris is notably more massive than Pluto, implies that their formation history must be quite different. Equally important is Brown's discovery of Sedna, which has an exceptionally large orbit, an elongated orbit. With its closest approach to the Sun, twice the distance of Neptune, and an orbital period of more than 11,000 years. The origin of Sedna remains a perplexing mystery. Two fascinating alternatives are being considered. In the early history of the solar system formation, Sedna may have been tugged into its current orbit by a passing star, or it may have been captured from a different planetary system. Jewett, Liu, and Brown succeeded in proving the existence of a voluminous, enigmatic, and richly populated Kuiper Belt stretching far beyond the orbit of Neptune. Their investigations of the Kuiper Belt composition and dynamics have brought far-reaching and fundamentally new insights into the early history and current state of our solar system. I ask David Jewett, Jane Liu, and Michael Brown to come forward to receive the 2012 Kavli Prize in Astrophysics from His Majesty King Harald.
Our next musical number is Sweet Georgia Brown, as American as apple pie. And taking a closer look at the host institutions for our laureates, you could think that that goes for this ceremony as well. But if you take a closer look, you'll see that the laureates originate from Europe, Asia, and the United States. And they have very different backgrounds. And in this sense, they represent the diversity of modern science in all its glory. But they do have some things in common, no matter where they come from. One thing is they come from families with a strong belief in the value of education. It's easy to think that most of them have specialized in a very early age, being so good at one topic. But it's not like that at all. On the contrary, they've had a great variety of interests during their life, and they have been doing a lot of extracurricular activities. And the third thing mentioned is that all of them have in their life a certain person, a professor, a teacher, an uncle, an aunt, who has been given them confidence to follow their dream of becoming a scientist. You will now meet a young musician. He is one of the talents that have been developed at the Barrat Due Academy, but he went, as so many in our country, west. He has had his education at Berkeley, from where he finished this spring, and is now studying at Manhattan Music School. Ladies and gentlemen, Felix Peikli with Sweet Georgia Brown.
One of the biggest scientific events of the past year has been the search for the elusive Higgs boson. Originally, it was proposed by the British physicist Peter Higgs and others almost 50 years ago. And this elementary particle has been the cornerstone of modern theoretical physics. The idea, roughly speaking, is that the Higgs particle, and along with the corresponding Higgs field, has the job of giving other particles mass, without which the universe wouldn't be what we know it to be. And it now seems to be close to a definitive confirmation, the confirmation of the Higgs. So the thought of this tiny particle giving mass to the entire universe reminds us how much of modern science, how much of science in the 21st century has involved going inside, dealing with smaller and smaller things. And in a way, nanotechnology is part of that big picture of extremely small things. And what a strange and surprising picture it is. Back in 1959, when the great physicist Richard Feynman urged scientists to make things out of individual atoms in a talk he called Plenty of Room at the Bottom, I wonder if he could have imagined how weird things would be down there at the bottom like that. At the nanoscale level, materials don't behave the same way they do up here at our big size. In fact, in ways, they seem to behave in ways that defy common sense often. Understanding how this happens is crucial for the advancement of nanoscience, enabling these tiny particles, these tiny domains, to open up onto vast new worlds. And the prize committee has recognized that fact this year. So the moment has come to honor the scientist with the Kavli Prize in Nanoscience. And each year up until now, each category of prizes has been awarded to 2 or 3 scientists at the same time. This year, for the first time, the award in nanoscience goes to 1 solo scientist. And the laureate is Mildred S. Dresselhaus.
The chairman of the Committee in Nanoscience, Arne Skjeltorp, will now justify the award. Skjeltorp is a professor at the Department of Physics at the University of Oslo, and he is head of the Physics Department at the Institute of Energy Technology.
Nanoscience is a science of the extremely tiny. It involves the study and manipulation of matter at the nanometer scale, about 100,000 times less than the width of a human hair. Just because the structures are so tiny, they have very special properties which are different from the properties the materials we use today. Therefore, some say that nanoscience is a big science of small things. Mildred Dresselhaus has done more than most to provide fundamental knowledge in nanoscience on which this new science has flourished. The story of carbon is interwoven with the history of nanoscience. As early as in the 1960s, Dresselhaus led one of the very first groups exploring carbon materials that presaged the discoveries of 2-dimensional graphene, fullerenes, and 1-dimensional carbon nanotubes. This resulted in 2 Nobel Prizes later for fullerenes in 1996 and graphene in 2010, as well as the first Kavli Nanoscience Prize awarded to Sumio Ijima. Actually, he is present in the audience, for carbon nanotubes in 2008. The present award honors Dresselhaus for her specific and pioneering advances in studying the vibrations of carbon atoms, named phonons, electron-phonon interactions, and thermal transport in nanostructures. Her experiments helped map out the moving patterns of electrons in their materials, critical to further understanding the unique properties they might possess. Dresselhaus revealed an unprecedented microscopic understanding of nanostructures' properties with an exquisite set of experimental techniques. She pioneered Raman spectroscopy as a sensitive tool for characterizing materials that are a single atom thick, as carbon nanotubes and graphene. The fundamental research has opened up new fields in how thermoelectric materials convert heat energy into electrical signals, or use electrical energy to cool a material. Normal materials have limited efficiency and utility by the strong links between the electrical and thermal conductivity. Dresselhaus improved our understanding of how energy flows and dissipates at the nanoscale and demonstrated that it is possible to separately adjust the electrical and thermal conductivity. This should allow the creation of new generations of thermoelectric refrigerators and new ways of scavenging waste heat for useful purposes. While an award could have been made for Mildred Dresselhaus' work on the nanocarbon field as a whole, the prize honors her for her specific advances in the study of phonons, electrophonon interactions, and thermal transport in nanostructures. She laid the foundation for our understanding of the influence of reduced dimensionality on the fundamental thermal and electrical properties of materials. Her work has provided a series of seminal contributions to the science of carbon-based nanostructures. Besides being dubbed the Queen of Carbon by her peers, Dresselhaus has also been a great role model for many students in the field. The exciting work of Dresselhaus is the hallmark of curiosity-driven basic research and in the Fred Kavli spirit. I ask Mildred Dresselhaus to come forward to receive the 2012 Kavli Prize in Nanoscience from His Majesty King Harald.
While most of us might not be eager to face a jury, scientists have to face the juries of their peers all the time. And science thrives on it. This happens in the arts, too, and often with just as rewarding results. This year, the jurors of the Young Stars Scholarship declared a young singer a great musical talent with a stage charisma like no other, and declared her the winner. Tonight, she'll be performing Voi che sapete by Mozart. Please welcome her now, Marcella Randem.
Painters will sometimes say that understanding the visual arts is about learning to see. This idea reflects the profound truth confirmed by the science of neurology. We do not actually see with our eyes, we do so with our brain. There might be some of you who think I've put on quite a loud dress today, but I can tell you that it's an experiment. I'm trying to see if I can make your visual cortex itch. The brain is a wondrous thing, and it is not only the seat of reason and emotions, it is responsible for receiving, processing, and storing the sensory data from billions of cells all over the body, in addition to the massive flow of live images from our eyes. The brain deals with sounds, tastes, smells, and the sense of touch. Using all these data, the brain creates our experience of reality on the fly. Exactly how it does this, we still don't know for certain. But what we know is that behind every simple, everyday experience, such as picking up an apple and taking a bite, lies a complex of mental processes involving different parts of the brain. If we want to understand these processes, we also need to know how sensory signals are generated, and we need to move through body, and how the brain responds to them. It is in this particular area of neurology that this year's recipients have made their mark. And so, it is time to honor 3 scientists with the Kavli Prize of Neurology. The laureates are Cornelia Bergman, Winifred Denk, and Anne M. Graybeal.
It's a great pleasure to introduce the chairman of the Committee for Neuroscience to justify the award. Dr. Jon Storm Mathisen is a professor at the Center for Molecular Biology and Neuroscience at the University of Oslo.
This year's Kavli Prize in Neuroscience goes to 3 researchers who in different ways have made discoveries that clarify basic neuronal mechanisms underlying perception and decision. Cornelia Bergman has pioneered the study of how genetic programs control the operation of neural circuits. She was the first to reveal the individual molecular and neuronal steps through which a behavioral response results after binding of a substance from the environment to a specific sensory receptor protein. By exploiting the simplicity of the nervous system of the roundworm C. elegans, Bergman has identified fundamental principles of neural circuit logic. The functional circuits in the worm are much like in our brain, but they are simpler and more amenable to genetic analysis. Winfried Denk has devised two experimental innovations of broad impact on studies of how individual neurons respond to synaptic inputs. He developed two-photon and multiphoton microscopy, which revolutionized high-resolution functional imaging in the living brain, making it possible to see ongoing physiological processes in structures as small as individual nerve contacts. Using this technique, he discovered that direction selectivity is computed locally in individual dendritic branches of so-called starburst amacrine cells in the retina, indeed a part of the brain. His other invention of serial block phase scanning electron microscopy has the potential of identifying all connections between brain cells, the entire connectome, the genome. By this technique, Denk revealed the wiring asymmetry between the starburst cells and the retinal ganglion cells, which convey motion information to the brain. And Grabiel has unraveled the modular architecture of the striatum and its connections with the cerebral cortex and discovered striatal plasticity underlying habit learning. Her analysis of how multiple loops between striatum and the cerebral cortex change when animals learn new skills reveals the way neuronal circuits organize familiar motor patterns into action sequences. The neural loops between cortex and striatum are also important for working memory and cognitive control and contribute to mechanisms involved in disorders such as schizophrenia, Parkinson's disease, and addiction. All of the three prize winners have done groundbreaking work on how the brain's nerve connections underlie behavioral reactions to sensory input. Understanding how the brain receives information from the environment and processes it to make decisions is a major challenge in neuroscience. The prize winners have addressed this question successfully in different organisms, from worms to primates. They have used a wide range of approaches and have invented new technologies of wide impact. I know it has been hard work, but I also know it's been great fun. It is all fundamental, curiosity-driven research, and thereby, indeed, culture. Mr. Kavli has put it like this: the curiosity of the human mind has taken mankind to where we are today, and there is no doubt it will take us to where we need to be in the future. I now call upon Corey Bergman, Winfried Denk, and Anne Grabiel to come forth and receive the Kavli Prize in Neuroscience from His Majesty King Harald.
You will now meet the Norwegian and international dance company Frikar. They were established in 2006. They have been touring 29 countries all over the world, and they consist of a network of 32 artists on 4 continents. National Geographic has described them as wildly inventive. And you will now see a vigorous and humorous dance routine performed by artists from 3 very different cultures: the Norwegian folk dance, the Brazilian martial art dance capoeira, and breakdance. Ladies and gentlemen, Frikar.
That was the Frikar Dance Company.
Yeah.
And thanks to them, now I know what Frikar means. Which is, in that one word has enlarged my Norwegian vocabulary by 100%. But you know, unfortunately, I'm not here long enough to learn actual words.
I think you're doing
I'm just
good.
concentrating on the Norwegian lilt. You know,
Lilt?
the lilt, you know, like when I say, "Oi, Vin Andersen."
Yeah, that's right.
Otsa Klebeland.
That's right.
But now that I know what a frikar is, you know, that it means someone who behaves unconventionally and earns respect through creativity and virtuosity, I'm proud to say, jeg en frikar. I know, it doesn't have the ring of Ich bin ein Berliner, but it's the best I can do. I'm still proud of it. Jeg en frikar.
Yeah, and it's great.
Thank you.
Next time we'll do that too.
Yes, let's
Yeah,
come out doing
okay?
that. Yes,
Yeah.
good.
Well, the characteristics of a free car, as you sort of put it forward, that could go for the next artist as well, although he's not a dancer. He is a musician, a young musician, 18 years old, and he won the European Championships in music this year. He won the Eurovision Young Musicians Contest. It's very hard competition, and you know, being a small country, we Norwegians, we love when our sportsmen or musicians and whoever win international competitions like this. And we're very happy for this victory. And you will now meet Eivind Holtsmark Ringstad. He's playing the viola, and he will perform with Oslo Camerata Andante e Rondo Ungherese by Carl Maria von Weber. Enjoy it.
It moves me very much. It moves me very much when I hear Fred Kavli talk about his childhood here in Norway, about the green valley he grew up in, surrounded by tall mountains, about how he could reach out and touch nature. His love of nature and the passion that he feels for understanding nature's mysteries is something that I find powerful and touching. And he loves to share that passion for understanding nature with others. I've heard Fred speak with unusual feeling about how he regards the Kavli laureates as his heroes. The story of Fred Kavli is a love story, a story of love between him and nature. And he's not jealous of nature's other lovers. He welcomes and even arranges dates for them. Fred Kavli and the Kavli Foundation has enabled generations to come to reach out and touch nature and love her as he does. He's helped make being human even better than it already is. Please welcome to the stage Fred Kavli.
Your Royal Majesty, Excellencies, ladies and gentlemen, we are here today to celebrate the accomplishments of our prize winners, our scientists, for taking great steps forward in humanity's journey to gain greater knowledge of the universe, nature, and the human being. From the dawn of time, when matter prevailed over antimatter 13.7 billion years ago, to the creation of the planet Earth 4.5 billion years ago, there has been a continuous drive in nature for greater refinement and sophistication. Nature has developed from the simplest forms over time to two-legged creatures 4 million years ago that developed skills with their hands to make tools and utilizing their brain and nature's resources to eventually become the master of the planet Earth. Embedded in nature and in the human being is the fight for life and survival and knowledge, the ability to compete and conquer, to explore and find new avenues to grow and develop. The development has continued at an ever steeper and steeper curve, and now we are in the age of discovery, becoming more fascinating by the day as we learn more about the secrets of the universe, its immense size, power, and complexity. And what we see out there is only 4% of what is out there. The rest is dark matter and dark energy. So what is dark matter? We don't really know, but we know that dark matter is known in part because of its gravitational influence on distant galaxies. Dark energy is even more astounding. Whatever it is, it's causing the universe to expand at an ever-increasing speed. But there are other mysteries. Will the new rover Curiosity that just landed on Mars last month find remnants of life on Mars? There are approximately 10 to the 24th power, that is 1 with 24 zeros behind it, suns, number of suns in the universe, and as many or more planets. It is difficult to see planets as small as the Earth at distant solar systems, but we have already found planets and moons that could support our type of life. If only 1 million planets, one in a million planets resemble the Earth, we would have a 10 to the 18th power number of planets that could support life. More than the number of grains of sand on all the beaches on the planet Earth. I think the universe is teeming with life. The black holes are incredibly dense and extinct stars that exert such massive gravitational pull on their surroundings that nothing can escape their grip, not even light. A super large black hole can have a mass of tens of billions of suns that they have digested. Black holes are residing at the center of most galaxies, and recent observations of the center of the Milky Way have revealed stars that are orbiting black holes at a very high speed. You may have heard about the flashes of light called gamma ray bursts, which may come from as far away as 13 billion light years, and are so strong that they light up the whole Milky Way galaxy, but not only the Milky Way galaxy, but the whole universe. Over the few seconds that the gamma ray burst lasts, it releases about the same amount of energy as the entire universe. Today, we are living in an age of great discovery as we are entering the quantum age, working with basic building blocks, the smallest particles of nature, the cells, the molecules, the atoms, and electrons. We are gaining understanding of the complexity of nature and life, and learning to harvest the ingenuity of nature's solutions developed over billions of years. Nanoscience burst into the spotlight in 1985 with the discovery of the buckyballs, resembling soccer balls, comprised of only 60 carbon atoms, as well as tiny crystals called quantum dots, and nanotubes came 6 years later. New discoveries open up whole new worlds, where very small particles, small amounts of material have new properties that differ radically from the properties of larger or normal quantities of material that we are working on. The rate of discovery is accelerating. Over the past 12 months, researchers have demonstrated single-atom transistors, 4-atom-wide nanowires, and the ability to store information using only 12 atoms, and a new class of computer memory. The first nanodrug uses nanoscale protein as a coating to eliminate toxic effects. I think the most exciting discoveries will come from the interfaces between nanobio and neurosciences. We can look forward to incredible advances in life sciences and in medicine using nano devices to create nanosystems, to understand and engineer biological circuitry and give us the foundation for personalized medicine. For many of us, the greatest reward in life is to gain more knowledge about the human being and the universe in which we live, to open new horizons, new vistas of the human mind, and to discover and understand nature. As we look at the development of the universe from the very beginning, we see the laws of nature working through natural selection for greater complexity and sophistication up to the creation of life and the human being. It is a history of survival through increased skills and knowledge. And each day, as I look at nature, the meadows, the trees, the flowers, the birds, the dolphins, the animals, and the human being, I hear a victorious cry for the glory of life. Thank you. I want to thank His Royal Majesty, the King of Norway, for his participation in the prize ceremony and for his presentation of the awards.
You know, Fred mentioned the mission to Mars, and it's just amazing to think that while we're standing here, a robot the size of a small car is driving itself around on the surface of Mars. And when, you know, as I'm sure you all know, when it started to descend onto Mars by use of a rocket-powered sky crane, scientists were just dancing with joy and with relief, too, because if the mission had failed, then billions of dollars would have just evaporated, and so would the work of hundreds of scientists.
Yes, and that reminds us how difficult and how time-consuming science is. The Curiosity project, it dates back to the turn of the century, and, well, probably researchers will work on this for decades to come. Scientists routinely dedicate a large proportion of their careers to projects like this. But most of them do it outside the spotlight, often enduring long working hours and not too much salary.
No, and what motivates them? The answer, I think the answer is right there, up on Mars, on the side of the vehicle. Curiosity. It's curiosity. The thrill of discovery, the joy of understanding something, learning something that has never been known before and never understood before. And we're all born with a sense of curiosity. You find curiosity in all kinds of creatures, whether they're pigeons, squid, or human beings.
And perhaps curiosity is one of the strongest driving forces in the evolution of life, beginning with the first lungfish that crawled ashore, wondering what lay beyond that beach. And so scientists we have honored here today are not just representatives of the 500-year-old tradition of modern science.
No, they're also the links, the newest links, in a chain that stretches back for hundreds of millions of years. Maybe the Greek philosopher Plutarch put it best when he said, "The mind is not a vessel to be filled, but a fire to be kindled."
Your Majesty, laureates, ladies and gentlemen, we are approaching the end of the Kavli Prize Award Ceremony 2012. And it is our hope that the Kavli Prize and its gathering here in Oslo over several days with representatives of scientific institutions, scientists, students. We have heard lectures by laureates and public outreach program, that all this will be a powerful contribution to the scientific community. As a last inspiration from this stage, here comes our grand finale.
Thank you for celebrating with us.
Thank you.
I got freedom, baby. Yes, I do.